Alright, hi guys. Today we'll be doing some trigonometry questions, which are all equation based. There will be no diagrams, no sine rule, no cosine rule, none of that. It's just equations. We have to prove some equations, solve some equations, stuff like that. So this will be for add math, and this will be for A levels, AS levels, and also some IGCSE focus as well. So let's get started. Show that equation 1 plus sine x into tan x is equal to 5 cos x. So first thing we need to know is that tan x is equal to sine x by cos x. And if you go to make that simplification, you'll get 1 plus sine squared x divided by cos x. This is equal to 5 cos x. Now take the LCM. That's going to give us cos x plus sine squared x, right? And the denominator is going to be cos x. You can take that to the right hand side to give us 5 cos squared x instead. And then we can write this as sine squared x is equal to 1 minus sine squared x, 1 minus cos squared x. So this will be cos x plus 1 minus cos squared x is equal to 5 cos squared x, which will give us 6 cos squared x minus cos x minus 1 equal to 0. So this was for 3 marks as an example of expressing one equation as another because they are equal to each other. Okay, second question. First thing you notice is that the keyword is hence, so you have to use the data from the previous question, previous part of the question. So this is going to be nothing but 6 cosine squared x minus cos x minus 1 equal to 0. And that is the summary, that is the simplification of this that we did in the previous part of the question. So this is a quadratic form over here, so we can find out the value of cos x simply by using the quadratic formula, which is going to be minus of minus 1 plus minus the root of minus 1 squared minus 4 into minus 1 into 6 divided by 12. This is going to give us, the under root is going to be root of 25, which is going to be 5. So 1 plus 5 is going to be 6 divided by 12 is 1 by 2. And 1 minus 5 is going to be minus 4 by 3. Minus 4 by 12 is going to be minus 1 by 3. So now I'm going to draw a part over here. First thing, another thing to notice, sorry, is that the domain is 0 to 180 degrees. So we have to use that. Now, the cosine value over here is 1 by 2. So x is going to have to be 60 degrees. And I have a calculator over here which shows that x is equal to 60 degrees. Now, we can use this diagram over here which says, which basically tells us in which quadrants, which trigonometric ratios will be positive and negative. So this is going to be all positive, sine positive, tan positive, and cosine positive. So all positive is just the theta value, which is in this case 60 degrees. This is going to be 180 minus theta, 180 plus theta, and 360 minus theta. Because dealing with cosine over here, cosine is positive, cosine of x is equal to something that is positive. So we're going to have to look at these two quadrants, which is quadrant 1 and 2, 1 and 4, sorry. So if you look at that, the quadrant 4 value for theta is going to be 300, which is outside the domain, so we can't use that. Next is going to be cosine inverse of 1 by 3. We have to take the absolute value, not the value given to us. So minus 1 by 3. So let's go over here and write that down. Sorry, like I said, not minus, it's going to be plus instead, which is going to be 70.53. So that is the theta value. Theta value is 70.53. Now, because cosine is negative, we can use this quadrant over here and this quadrant over here, which is going to be 180 minus 70.53 and 180 plus 70.53. 180 plus that will be something greater than 180, so we can't use that. We have to use 180 minus that. So what I'm going to do is 180 minus answer over here, which is going to be 109.47. So those are going to be the answer. The answer is going to be this. All right. Next question. 3 sine 2 theta into tan theta is equal to 2. We have to solve this equation. All right. Easy enough. Sine 2 theta is equal to 2 sine theta into cos theta, and tan theta is equal to sine theta by cos theta, and this is equal to 2. So straightforward, this cancels out, this cancels out, this 2 and this 2 cancels out, so we get sine square theta is equal to what? 1 by 3. So we get sine theta is equal to 1 by root 3 and minus 1 by root 3. So using that, we can get theta is equal to, again, the domain is 0 to 180 degrees. So let's go. Theta is equal to sine inverse of 1 by root 3. So we get sine inverse of 1 by root 3, which is going to be 35.26. So this is going to be 35.26. Now we notice that theta is positive, so sine theta is going to be between in the first quadrant and the second quadrant. The second quadrant is going to be 180 minus theta, which we can use. So I'm going to write that over here, 180 minus theta, which is going to be 144.74. Now the next one is going to be the sine inverse of the positive absolute value of 1 by root 3, which you already know is 35.26. But now because it's negative, we can use something else. We have to use the third quadrant. Third quadrant is going to be 180 plus that, and 180 minus 144.74 is basically what we're going to get. So those two are the same values. Because so it's going to be 180 plus minus 35.26, if that makes sense. Which is equal to this. So those are the two solutions for this. All right. Next question. Prove the identity that 1 by cos x minus tan x whole square is equal to that. Okay, this is a bit complicated, so be ready for it. First thing we're going to do is simplify the bracket. It is going to be 1 by cos x minus sin x by cos x, which is going to give us a simplification is going to be 1 minus sin x by cos x, right? That is the simplification. So what I'm going to do is write that down elsewhere. I'm going to just erase this over here. All right. So the simplification is going to be what? 1 minus sin x by cos x squared, right? Which can be simplified by dividing it into numerator and denominator. So it's going to be 1 minus sin x whole squared divided by cos squared x. Cos squared x we already know is 1 minus sin x. 1 minus sine squared x, which is nothing but difference of squares, right? So I'm going to write that as 1 plus sine x and 1 minus sine x. All right. Now next, 1 minus sine squared x can be written as 1 minus sine x into 1 minus sine x. So 1 minus sine x into 1 minus sine x. So 1 minus sine x, 1 minus sine x gets cancelled out, and we are left with 1 minus sine x in the numerator divided by 1 plus sine x in the denominator. So that's going to be the answer. That's going to be the proving of the identity. Now 1 by cos 2x minus tan 2x whole square is equal to 1 by 3. And we already saw that that is simplified into 1 minus sine x and that. So if the x is replaced by 2x, it's going to be the same thing. It's going to be 1 minus sine 2x divided by 1 plus sine 2x. So it's going to be 1 minus sine 2x divided by 1 plus sine 2x is equal to 1 by 3. Simplify that, you get 3 minus 3 sine 2x is equal to 1 plus sine 2x. And we can simplify that to give us 3 minus 1 is 2 is equal to 4 sine 2x. So we get sine 2x is equal to 1 by 2. All right, so 2x is equal to what? That's going to be 60 degrees. No, that's going to be 30 degrees. And because it's positive and it's the domain of, well, this is in radians, okay? So what I'm going to do is write that as pi by 3 instead. Yeah, so sorry. Yeah, so this is going to be pi by 3 radians. And again, all sea turtles crawl. It's going to be positive, right? So it's going to be in this domain over here, which is going to be 180 minus theta or pi minus theta. Pi minus theta in this case is going to be 2 pi by 3, right? So this is going to be that and 2 pi by 3. Now, if you simply divide those two sides by 2 to get the value for x, you will get pi by 6 and pi by 3. So x is equal to pi by 3 and pi by 6. That's going to be the answer. Another thing, however, would be that pi by 3 and 2 pi by 3. So the next answer for 2x would be add pi to it, which obviously would be outside this domain, but pi plus pi by 3 is going to be 4 pi by 3. Divide that by 2, you get 2 pi by 3. So that's going to be another answer. After that, it will be 2 pi by 3 plus pi, which is going to be 5 pi by 3. Divide that by 2, we get 5 by 3 is 6. So 5 by 6 pi, which also works. So there are going to be 4 answers for this. The function f is defined by f of x is equal to 2 minus 3 cos x for the domain, which is 0 to 2 pi basically. So state the range of f. So first thing I'm going to do is analyze this function. So 2 minus 3 cos x, right? I'm going to write this in a different way. It's the same thing, but just makes it easier for me. So if you look at this, first thing is that it's a curve. That's one thing. And it's a negative cosine curve, which will mean that the cosine curve normally is like this. But because it's negative, it's going to be like this. The minus 3 shows us the amplitude. So it's going to have if this was the resting point, then this is going to be 3, and this is going to be 3 units. Now it says that there's a plus 2, which means that it got transformed 2 units up, which basically means that the resting point is not the x value, it's not the x-axis, it's going to be the y, it's going to be it's going to be y equal to 2 instead. So what I'm going to do is I'm going to draw the graph over here, even though it comes later in the question, I'm going to draw it right over here. So the graph will look something like this. So we have the x-axis, y-axis. This is going to be x equal to y equal to 2, because that's going to be the resting line, so y equal to 2. And if you look at it, this has a period of 2 pi. So I'm going to just write 2 pi over here. I'm not going to be too concerned with the values. I just care about the points. So it's going to start at minus 1. Why? Because the 2 minus 3 is going to be minus 1. So that's going to be the lowest point. So minus 1. And the highest point is going to be 5. And it's going to go something like this. Well, technically at 2 pi is going to be at minus 1. So it's going to look something like that. And this is going to be 3. This is going to be 3. Because it's a negative, it's going to start and go in that direction. So I'm going to modify it a bit. It's going to be something like that. All right. That's the best I can do. So what's the range of this going to be? Range is going to be 5 to 1. So y is like this. Yeah, so sketch the graph. I'm going to use a different color this time. This is y, this is x, this is going to be 2 pi, this is going to be pi, this is going to be what? 3 pi by 2, and this is going to be pi by 2. This is going to be minus 1, this is going to be 2, and this is going to be 5. So it's going to start from this, it's going to start from this. It can be something like that. That's the best way I can draw it. Now, the function g is defined as that. So g of x is equal to 2 minus 3 cos x for 0 less than equal to x less than equal to p, where p is a constant. So state the largest value for p with, of p for which g has an inverse. Okay, so what does it mean for an equation for a function to have an inverse? It needs to pass 2 tests. So I'm just going to use this graph that I have over here and use a different color. So there are two things. There's a relation and a function. A relation could be something like x squared. All right, y is equal to x squared is a relation. Let's assume that. Now, if that relation passes the horizontal or the vertical line test, which means that if I were to draw um, any vertical line, then there'll only be one intersection point with the curve, and that is correct, right? So that relation then becomes known as a function. So y is equal to x squared. If I were to draw over here, y is equal to x squared, it passes a vertical line test, right? So it's a function, yes, but it's not an inverse function. It does not have an inverse function because it does not pass the horizontal line test. Because for every intersection in the horizontal axis, in the horizontal manner, there will be at least 2 intersections, unless you look at the zero root over here, right? The vertex over there. Same thing in the cosine curve over here. It does not pass the horizontal line test, so it's not a bijective function and does not have an inverse. So what we have to do is make sure that for it to have an inverse, what I'm going to do is draw the graph over here again. Minus 1, It is 2, right? Yeah, this is 2. If you were to simply divide it over here, what is that value going to be? That's going to be pi. What do you see? If you forget the rest of it, so what I'm going to do is just highlight it. This part over here, oh, color sucks. Sorry. Let's use blue. So this part over here, I'm just gonna just blur it out. Um, just forget about it. It still exists, but we're going to restrict the domain in such a way that we forget about it basically. So now continuing with the pen, what do you see over here? It passes the vertical line tests, yes, and it passes the horizontal line tests as well. So the largest value for p, where the inverse actually exists, is going to be pi. So p is equal to pi. All right. Now, for this value of p, find an inverse of g basically. So we know that g of x is equal to 2 minus 3 cos x. So g of x is equal to 2 minus 3 cos x. And the best way to approach this, in my opinion, is make y equal to this and make this x over here the sum of the formula, which is going to be y minus 2 divided by minus 3. So y minus 2 divided by minus 3 is equal to what? Cos x. So x is equal to what? Cosine inverse of y minus 2 divided by minus 3. Now g inverse of x can be written as cosine inverse of x minus 2 divided by minus 3. So that's going to be the answer for the expression for the inverse of the function. All right, next question. Show that 2 cosec 2 theta into cot theta is equal to cosec squared theta. All right, cosec theta is nothing but 1 by sine. So this is going to be 2 by sine 2 theta into cot theta is nothing but 1 by tan theta, and tan theta is going to be sine theta by cos theta. So if you were to inverse that, this would be cos theta divided by sine theta. And I'm not going to write that equal to over there because we need to prove it, right? So we don't need the right hand side. We can just show that at the end. So sine theta is equal to what? 2 sine theta cos theta. So 2 cancels out, and this is multiplied with cos theta by sine theta. Cos theta and cos theta cancels out. So this gives us 1 by sine squared theta. And we know that 1 by sine squared theta is equal to cos x squared theta. That's it. That's the proving part of it. Now, hence, show that that is equal to 4. So the best way to do this would be look at this part over here. It says that cos x squared something into tan something is equal to 14 is equal to 4. So if you look at this, I could write the previous equation as 2 cosec theta, 2 cosec 2 theta into 1 by tan theta is equal to cosec square theta, right? So I get 2 cosec 2 theta is equal to cosec squared theta into tan theta. And in this case, we have cosec square theta. So we have theta equal to 15. So I can write that as 2 into 1 by sine 30. Right? What is that going to equal? This is going to equal 4. And how? Well, sine 30, if I go over here, sine 30 is equal to 1 by 2. So 2 into 1 by 1 by 2 is equal to 4 now. So 4 is equal to 4, we proved. That's it. Now, solve the equation that 2 cosec phi into cot half phi plus cosec half phi is equal to 12 within the domain, which is minus 360 degrees less than phi, is greater than phi, sorry. Wait, minus 365 like that. Okay, whatever it is. Now, first thing I'm going to do is make a substitution. Half phi is equal to, let's say, theta. This is just phi by 2 is equal to theta. So I'm going to write that as 2. If phi by 2 is theta, then phi is equal to what? 2 theta. So this will become 2 cosec 2 theta into cot theta plus cosec theta, right? I'm going to simplify this side and then work on the other side. So cosec 2 theta is going to be 1 by, oh, it's going to be 2 by 2 sine theta cos theta into cos theta by sine theta. Cos cancels out. So this is going to be that, and then cosec theta. So sine squared theta, 1 by sine squared theta is nothing but cosec squared theta. So this is going to become cosec squared theta plus cosec theta minus 12 is equal to 0 because 12 is on the right hand side. So we take out that. This over here is going to give us cosec theta equal to what? Now, we can use the quadratic formula or we can use our calculators. So this is a calculator over here. For the GDCs, we can use this, which is going to be what? It's going to be 1 minus 12. So 1. So the answer is going to be 3 and minus 4. So cosec theta is equal to 3 and minus 4. So we can write that 1 by sine theta is equal to 3. So sine theta is equal to 1 by 3 and 1 by 4, but negative. So you get theta is equal to what? Well, first off, note that this is in degrees, so I'm going to have to write this in degrees when I do start. This is, make sure that this is in degrees, and this is going to be sine inverse of 1 by 3, which is going to be 19.47. Now, this is in the, this is 5 marks mainly because of the domain that we're given. It's the negative side and the positive side, which makes it a bit more complicated. So look at this over here. All see turtles crawl. Sine is positive, which means that it's going to be in this one as well. So if you do that, it's going to be 180 minus that. Which is going to be 160.53. So these are two of those answers. The next one you're going to have to use minus 1 by 4. So sine inverse of 1 by 4 is going to be what? Positive value, obviously. So you're going to have 14.48. So you're going to write x is equal to 14.48. All right. Now it's negative, so it's going to be in this one and this one. So it's going to be 180 plus that, 180 plus 14.48. 194.48. So, and then the last one is going to be 360 minus that. So I'm just going to go over here. 374.48. Now, of course, this doesn't count. So, no, it still does count. Sorry. Remember that you have to divide it by 2. Because with the substitution I made before, theta is equal to 5 by 2. So we need to find out 5. Pi is equal to 2 pi, 2 theta. So actually, no, this does not count. And this doesn't count either because that's going to be greater than that. So this is going to be the main answer. So what I have done over here is simply expanded this fraction over here. And the next thing to do would be to convert this into cos and this into sine. So you'll get sine theta minus cos theta into 1 minus cos square theta minus sine theta into 1 minus sine squared theta plus cos theta. Sine theta minus cos theta plus cos cubed theta minus sine theta plus sine cubed theta plus cos theta. So cos theta minus cos theta sine theta minus sine theta, we're left with only this. Which just hence that proves that. So this is going to be what now? Sine cubed theta plus cos cubed theta simplify it, so we get sine cubed theta is equal to 2 cos cubed theta divide, take the cos over there, this will give us tan cubed theta is equal to 2. right? Then take the cube root and take the inverse, and sorry, yeah, so theta is going to be equal to the tan inverse of the cube root of 2. It is going to be, using our calculator, go to tan inverse. 51.56. Next is going to be when tan is positive 180 plus that. So 180 plus 51.56 is 231.56. That's it. Alright, that'll be it. Thanks for watching. If you do have any more questions, just put them in the comments. I will answer them whenever I can.